Okay, guys, I'm currently sharing my slides on example of the rate determining step. Can you guys see the slides?
Yes, madam.
Yes, madam.
Yes.
Yes.
Okay, thank you for the response. Okay, let's continue. Okay, all right. So the last slide ataupun the last subtopic that we have discussed earlier on, we have the rate determining step, or in short, we can call it as we can call our rate determining step as RDS. Okay, all right. So RDS is the step that is usually much slower than the others. Okay, and therefore it is called the rate determining step. And this rate determining step is usually directly related to the rate law for the overall reaction. Okay, because it is the slowest, therefore it determines the rate of the whole reaction. Okay, whether the reaction progress faster or slower, it depends on this rate determining step ataupun it depends on this slowest step. Okay, all right. So that's the key point that you have to take note on, that this one, ni paling penting the rate determining step is directly related to the rate law for the overall reaction. Okay, all right. So look at example. So the proposed mechanism of the reaction is the following two-step sequence of elementary reaction. Okay, all right. So these are the two elementary steps. Number one and number two. As you can see, we have the slowest reaction, okay, which is reaction number one, whereas reaction number two is faster compared to reaction number one. Okay, so you have to identify the rate determining step and reaction intermediate and or catalyst if we have the catalyst in the reaction. Okay, all right. So, we have two questions here. Okay, so identify the rate of determining step. So which one would be the rate of determining step? Simple. Okay, the slow reaction will be the rate determining step. Okay, all right. So the first elementary reaction is slow, so it is the rate determining step. Somebody, Yasmin, you forgot to mute your mic. Okay,
Oh,
so
sorry.
please make sure that you mute. Okay, tutup mic awak. Okay, all right. So it is the rate determining step. So the first one will be of the rate determining step lah. Okay. Okay. So the first one. So thus the rate is equal to identify the rate determining step and then the reaction intermediate. Dia tak tanya pun the rate law. Okay. Identify the rate determining step. So the rate determining step is step number one. Okay. All right. So actually, okay, if you were to apply what we have learned before, we know that we can write the rate law of each elementary step, okay, by using the molecularity that we have in the from the chemical equation. Okay, kalau soalan tak minta, saya saja just nak write the rate law for each of the elementary step. You can write it as rate is equal to K NO2 Cl kuasa 1. Okay, because we only have one reactant there. As for reaction number 2, we have the rate law as rate K NO2 Cl kuasa 1 Cl also, the order is also 1. Okay, and then you can also write the overall equation from this given elementary reaction. Okay, so sebenarnya banyak sangat soalan boleh tanya from this reaction from this elementary step. Okay, so as you can see, it's not given. The general equation, the overall equation is not given, but you can write it on your own. Okay, based on the cancellation of intermediate and also catalyst if we have one. Okay, all right. So NO2, let's say lah, kita nak prepare the overall equation. So how do we write the overall equation? Okay, NO2Cl, we have 2 here, 1 dekat sini, 2 dekat sini. That means it will be 2NO2Cl. Sebab dia tak cancel kan? How about Cl? Cl, this one can be cancelled out. So it will not be displayed in the overall equation. How about others? NO2 we do have on the same side, and Cl, okay, it cannot be cancelled as well. Okay, so we have 2NO2Cl. Okay, and that is all for the reactant producing 2NO2. See, 2NO2 plus Cl. We only have one Cl2. Do we have a catalyst in this reaction? No, we don't. Okay, we don't have catalyst in this reaction because the characteristic of catalyst is not present in these two reaction method, in these two elementary steps. Okay, but we do have reaction intermediate. So this Cl and Cl is the reaction intermediate. Okay? Alright, so from this overall equation, sebenarnya from this overall equation, okay, Cl. Is it 2? Tu kan? NO2, NO2. It's the same thing kan? NO2Cl, NO2Cl. Okay? Alright, so so the rate law for this one, remember for the overall reaction last time? Okay, for the overall reaction, what we can do is that we can come out with the general rate law, because overall can only be determined through experiment, right? So it should be rate is equal to K NO2 plus Cl raised to the power of M. But this is overall. We are talking about overall. Okay. All right. So the one that we have learned so far, if we want to determine the order for the overall reaction, okay, it must be determined from experiment. So that's why saya letak M dekat sini. But remember this statement here, statement dekat sini, is directly related to the rate law for the overall reaction. Okay, it's directly related to for the overall rate law reaction. Tapi this one is not the same. Okay, it's not this bukan sorry, it's not the same apa. Dia kata the slow, okay, will be directly related to the overall reaction. Apa yang you boleh nampak persamaan dia dekat sini? The rate sama lah, KK sama. We do have the NO2Cl in it. Betul tak? Betul ke tak betul dekat situ? We do have NO2Cl in the slow rate law, which also present in the overall rate law. See? Okay? So ini adalah cara prediction that we can predict the overall rate law from the elementary step. Okay? Alright. So normally dia akan directly related. So we can determine. Okay? Alternatively, we can determine that M is equal to 1. Okay? Jangan pergi ambil ni pula. Jangan ambil 2 pula ya. Matrix is equal to annotate the shared content. Stop. Annotating. Saya decline dululah nak faham annotation ni maksudnya apa lah? Maksudnya macam saya buat ni kan, annotation kan? Note ni kan? Betul tak? Okay, as of now saya try to decline first. Okay, Batrisha. Yeah, so this would be the prediction from the overall, and when we try to correlate with the slow rate law, kita boleh dapat almost the same. Nampak tak? Macam sama kan? Slow dengan overall rate law. Okay? Alright. So Cl is the intermediate. Okay, moving on to another example. The gas phase decomposition of nitrous oxide is believed to occur in 2 elementary steps. Okay, X. Oh, okay. All right. So we have step 1, step 2. These are the elementary steps to decompose nitrous oxide. Okay. So experimentally, the rate law is found to be rate is equal to K raised to times concentration of N2O. This is the rate law for the overall reaction, because it is mentioned here experimentally. Okay, all right. So this is the overall rate law. But do we have the overall equation? No, it's not given to us. But can we write one? Yes, we can. Okay, we can simply write the overall rate law from the elementary reaction that we have here. Okay, so soalan pertama dia, this is just information. Okay, maybe it will be useful for you to use later on. A, write the equation for the overall reaction. Okay, so how do you write the equation for the overall reaction? Okay, you eliminate the reaction intermediate and also catalyst if we have one. Okay, all right, N2O, N2O, N2O. Okay, we have one reaction intermediate here. Oxygen, oxygen, nitrogen, nitrogen. So this one will be total up. This one, can it be cancelled with another oxygen? No. Okay, all right, when we total up, we have 2N2O. Okay, so that will be the only reactant we have producing N2 plus N2 will be 2N2 plus O2. Make sure that it is balanced, okay? Alright, itu memang basic steps lah. When you have equation, you have to make sure that it is balanced. Okay, don't just simply cancel out. You have to make sure that it is balanced. Belah sini ada 2, ada 4 nitrogen. Here, you should have 4 nitrogen. So that is basics. Okay, all right. So this is the overall equation. So you have it already. And then identify the intermediate. So the intermediate is the one that present as the product for the initial reaction and then present or will be used as a reactant for the following reaction, which is in this case is oxygen. Oxygen atom, not oxygen, not this one, not O2. Don't just simply letak O2, salah ya. Okay, it should be O. Because we do have O2 here. Jangan salah dekat situ. Okay, right. Identify the rate determining steps. Okay, guys. You have to identify the rate determining step. So, the difference between this question dengan the previous one just now, previous one, dia dah state, okay, which one is the slowest, which one is the fastest. It's just that for this question, it's not stated. That information, okay, are not stated on either of the elementary reaction. Dia tak lagi. But how do we determine which one is the slowest? Kita boleh guna from this one. Okay, so this would be the experimental rate law determined by this would be the rate law of the overall reaction lah. Okay, because when we talk about experimentally, that means it is referring to the overall rate law. So the rate law for the overall will be K and statement tadi yang kata dia mesti directly related to the rate law for the overall reaction. Okay, alright. So kita look for mana tadi? This one. Okay, we look for the one that has N2O lah. The easiest one will be the one that has N2O in it. Okay, this one kita boleh come up with dia punya rate law kan? Elementary step. Okay, so the elementary step for step number 2, the rate law is equal to K N2O. Okay, to the power of 1, the order is 1 times O, right? Times O. Tepi lah benda. Okay. Okay, 1, 1. Right? Okay, how about for step number 1, rate is equal to K and 2 O to the power of 1. So which of these two steps has the same rate law as the overall, guys? The same rate law as the overall. Step number 1. Okay? So bila this sama, that means we could say that step number 1 is the slowest. Bila dia slowest, it is the RDS step, the rate determining step. Okay, faham ya? So cara macam tu kita determine dia. So normally the overall rate law would be directly related to the slowest rate law. Sebab dia punya reason dia, the slowest rate law will determine the whole the rate of the whole reaction secara keseluruhan. Okay, right. Step 1 is the rate determining step. Okay, checkpoint 14, the last checkpoint. Lama ada 2 pula checkpoint dia. Okay. Let's go through together. Okay, checkpoint 14, a chemical reaction takes place in the following 3 steps. Ada 3 step pula. We have 3 elementary reactions. Step 1, step 2, step 3. And then it is stated here that step 1 is the slowest and the rest of the steps are fast. Okay. Add the 3 steps to show that it gives the correct overall reaction. Macam pelik je. Okay, dia tiba-tiba dah bagi ni jawapan ke apa ni? Add the 3 steps to show that it gives the correct overall reaction. Is it the answer? Is this one the answer? Okay, alright, so you have to add all these 3 steps, whether it can give you, you have to add all these 3 steps to produce the overall equation. Okay, right, to produce the overall equation. So make sure lah, kat sini ada banyak kan, you have to identify carefully which one is reactant and do we have catalyst in this reaction. Okay, right, do we have catalyst in this reaction guys? Cuba very quickly you tengok, ada tak characteristic of catalyst present in this reaction?
No.
Okay, ada ke? Tak ada HBr.
No.
Okay,
Yeah.
do we have it? HBr. BR. Okay, I don't think that we have catalyst in this reaction because catalyst, okay, normally dia akan diletakkan at the beginning of the reaction, which is here, and then dia akan present at the end of the reaction sebagai product. Okay, so do we have that characteristic for any of the substance present in any of the steps here? No, we don't have that. Okay, alright, so kita tak ada lah. Yang kita ada reaction intermediates definitely lah ada. Okay, alright, so we have to cancel out yang mana. So this one should be cancelled out. And then how about the rest? Oxygen, do we have oxygen? No, this is the only oxygen that we have. HBr, so these two, we have HBr here, HBr here, HBr here. So both of them, bukan both, all of them are on the same side. And then how about HOBr? Okay, so we have HOBr, 2 HOBr here, another 2 HOBr there. Okay, alright, so we have 2 reaction intermediates so far. So total cancellation. Okay, I think that is all. Okay, right, so HBr, another 2 HBr, so we have 4 HBr. And then don't forget, we have another reactant there, so we have O2. Okay, so HBr, HBl, this one all settled. And then we have 2 H2O as a product. We have other H2O other than this one? No. Okay, plus 2 Br. Okay, so this is also the only Br2 present. Okay, so basically it's the same as what we have here. Okay, right. Identify any reaction intermediates or catalysts. So we don't have intermediate catalysts. Okay, we don't have this one, but we do have intermediates. So it is HOOBr and HOBr. HOOBr and HO. Identify the rate determining step. Okay, so it will be the slowest lah. The slowest will be the rate determining step. Okay, alright. And then boleh nampak ketalian dia, tally Maksudnya this one kalau we were to write the rate law, we will get K, HVR, 2, right? Or both of them will have order equal to 1. Whereas kalau overall, at least we can predict, kita boleh predict Overall mesti daripada eksperimen, tapi at least kita boleh predict macam ni. Rate is equal to K, HPR raised to power of m, O2 raised to power of n. But this is overall. Kita by right lah. Kita tak boleh determine the order directly. But we can. So alternatively, kita boleh make sure dia directly correlated tak? Directly proportional. Not proportional, directly related. Okay, so HBR, we do have HBR. O2, we do have O2. So we can, maksudnya kita boleh tallykan dia. So kita boleh kata that the rate law of the overall reaction is also 1 for HBR. And this one, O2. Also 1. Okay, ini you guys belajar yang paling simple tau. Ada keadaan di mana dia kebetulan tak sama. The slowest rate and the overall are not the same. Yang tu yang kita discard from our syllabus. Last time we do have that, but now we don't have it anymore. Okay, so that's why I said just now, this is like the surface. So far yang you belajar, the slowest rate will be directly related to the overall rate law. Okay, right. No catalyst. See? Okay. Question 15, last question guys, penutup. Okay, given the following mechanism, so we have 2 steps, dan stated there we have slow and fast reaction. Right? Ni kenapa dah ada jawapan ke ni? Dah ada jawapan. Checkpoint 15 tu dah ada jawapan dekat awak punya answer, dekat awak punya soalan.
Madam. Belum. Tak ada.
Kau
Saya punya tak ada.
ya ke? Baik. Okay.
Dalam lecture note tak ada tapi madam punya nampak lah.
Tak, kat saya ada Oh, dekat awak punya tak ada. Okey, tak apa. Habis macam mana saya nak pandang pun dah tak sempat. Okey, tak apa. We can go through it together. Okay, given the following mechanism, so we have 2 steps. So, you nampak tak dia punya pattern dia? Okay, the pattern for the question, they are almost the same. So write the equation for the overall reaction. So you total up these two to get the overall equation. Okay, alright. So this is the overall equation. Identify whether we have catalyst and also the intermediate in this mechanism. So do we have catalyst in here? Kena identify betul-betul. Okay, alright. So O3, we don't have O3. That's the final in second step. NO, but we do have NO. That's the final product. Okay, alright. So therefore, NO is the catalyst. Okay, alright. How about the reaction intermediate? So NO2, NO2. Okay, so this NO2 is the reaction intermediate. How about O? We have O, we have O2. O2 will be total up. That's why we end up with 2 oxygen. Yes. O3 plus O will be the reactant lah, the only reactant left. Okay, alright. So that is all, guys. Any question related to topic, bukan topic 1. Topic 1 daripada awal. Okay, any question related to rate determining step? Or we proceed to topic 2.
Madam, checkpoint 9 dengan 10 belum lagi di-discuss.
Checkpoint 9 and 10. Which one? Jauh ni. Tajuk apa tu? Oh, integrated. Integrated.
Yeah.
The decomposition of hydrogen, kita reverse sikit. The decomposition of hydrogen iodide is shown by the following equation. So this is integrated under subtopic of integrated rate law. Okay, the rate constant of the reaction is 1.6 is given at 700 degrees Celsius. If the initial concentration of HI in a container is this, calculate the time taken for the concentration to be reduced to this in minute. Okay, all right, so you have to identify the order of this reaction first, because in, because okay, you need to know which formula that need to be used with respect to this question. Okay, all right, but it's no problem. We can determine the unit of we can determine the order of this reaction subject to the unit of the rate constant. So it's given here. Okay, so the unit the unit of the rate constant is this, which can be simplified into m -1 as -1. Betul tak? Sama kan? Patutnya dia mole liter -1, but it's the other way around. So therefore dia m -1 as -1. Okay, that's why saya tak berapa suka kalau dia mole liter ni. Saya suka simplifykan dia in this form, but dia less complex. Okay, okay, alright. So this is order berapa guys?
Second.
This is second order. So the moment you tahu the order of the reaction, it will be easier lah. The following step will be easier. Just insert into the formula. Okay, alright. So the initial concentration is given, and then you have to calculate the time taken. Okay, jom nak try. Saya pun nak try juga. Saya ingat ke tak formula of the integrated rate law for second order. I remember dia 1 per something. It will be positive value here. Okay, KT, sebab dia the only second order graph will be the only graph yang positive, having positive slope. Okay, alright. Okay, so we want to find the time taken in minute. This one is provided. This one, these two also should be provided. Okay, to be reduced to. Ini baca soalan betul-betul. To be reduced to, maksudnya this is what is left. Okay, ini yang tinggal. You kena faham, A at T time means yang tinggal pada ketika itu. So, bila you baca, you must make sure that maksud dia tu yang tinggal pada ketika itu ke ataupun yang lost. Yang dah lost and becoming product. Okay, alright. So, masukkan je lah dalam formula. So, this is the answer. Okay, alright. Moving on. Make sure that you convert into minutes, okay? So what we have here is in second, guys. You have it in seconds, so you have to convert into minutes, okay? Checkpoint number 10. The change in the concentration of hydrogen peroxide over time is shown in the graph below. Oh, yang ni. So dia dah bagi graph is given to you. And then dia bagi dalam bentuk kata graph ni. Memang betul-betul you kena guna plot the given lah. Besarkan sikit so that dia enhance. Okay, determine the order of reaction for the above reaction. See how do we determine the order of the reaction? And what is given to us is the graph of concentration versus time. So what is the method that we can use in order to determine the order? Do we have the unit of rate constant? No, it's not given. Okay, so what is our option now, guys? What can we do? How do we determine the order? Using the graph that.
Half-life method.
Yeah, that is correct. By using half-life method. Okay, so you kena buat half-life lah. Okay, because we have the initial concentration is given to us. So you kena tahu the characteristic of each order for their half-life. Okay, alright. Yang paling senang if it's first order, the T half, the half-life will be constant. The value will be constant. You dapatkan first half-life, second half-life, you check whether it is a constant value. If it's constant, that means definitely the first order. Okay, if it is zero order, apa ni? Zero order, dia punya T half dia, is it decreasing ke increasing ah? When the
Decrease.
concentration dia decrease, the time taken will increase, is it? Concentration, the initial concentration, dia punya formula apa?
Betul madam.
Decrease or increase? Increase kan?
Taken longer.
Longer kan? Longer,
Ha.
longer. Bila concentration decrease, it will take longer for the concentration to become half. Kalau second order is the other way around. Okay, T half would be, ni check balik make sure. Saya rasa macam ni. You can always use the formula. Okay.
Then terbalik. Zero order dia makin shorter. Second order makin longer time dia.
As the concentration decrease, it gets shorter. Is it?
Betul.
Okay, apa formula dia? Formula dia apa? T half is equal to? T half is equal
A naught over 2K.
initial concentration over 2K.
Over 2K.
Okay, so when the concentration is decreased, the T half will also decrease. They're directly proportional. Okay, when the concentration is decreased, so the time taken will decrease. Yeah. Okay, and this one, they should be the other way around. Okay, when the concentration is decreased, the T half should be longer lah. Longer. It's the other way around. This one constant senang. Okay, so you kena check lah kat sini. You check 0.9, half of this will be 0.45, which is around here lah. Ni yang kena enhance sikit kena besarkan sikit. So, ni ke curve. Turun, it's around here lah. Katalah, around here. Which is 100 something. Okay, so kita kena half of this 0.45. Kita kena at least ada 2 half-life lah. 0.5 will be, 0.225, is it?
Betul madam.
Oh yo. 0.225.
225.
Kecilnya. Further the dashes line, make sure that it touches the curve. Around here lah, okay. You check. Okay, alright, so you check from here to here, berapa the T half, the first T half. And then you check from here to here, berapa the second T half. Okay, looks like macam dia constant je. Is it constant, guys? Or is it decreasing? Decreasing ke? Okay, check balik lah. And then 0.225 kalau nak further checking, okay, you can half of this 0.225 will be around here something. Okay, just nak check. Saya rasa macam constant ni. Okay.
Dapat constant madam.
Dapat constant. Lebih kurang sama ni kan. Lebih kurang sama. Okay. Alright, so you check, you confirmkan the first T half, what do you get? And then second T half, berapa you dapat? And then is it constant? The value lebih kurang sama tu maksudnya constant lah. Okay, lebih kurang sama. Janganlah. Kalau dia beza banyak that one dia obvious kan? Maksudnya it's either zero or second order. Okay? Alright, so it is first order. So once you dah tahu dia first order, okay, so the rest will be easy lah. Okay, you should be using the first order integrated rate law. Okay, question B, determine the rate constant. Okay, determine the rate constant. This one you can pick any value from the graph. Okay, you can pick any value of the graph and then you can write the rate law. Betul tak? You dah determine the order kan? So rate is equal to KH2O2 right, to the power of 1. Betul tak? This is the rate law of the reaction. The order of H2O2 is 1. And then this is the only reactant present. Okay, alright, so how about the rate? Macam mana cari rate determine the rate constant. So concentration, kita find out the slope, is it?
Guna load dia ada
Oh,
boleh.
Okay, kenapa nak susah-susah? Okay, rate law, okay, dia macam ni ada banyak possible option lah, tapi you kena pilih yang mana yang sesuai, yang mana yang tak menyusahkan hidup kita. Kalau rate, okay, we have this one and we also have, sorry tau. Kita nak cari this one, but we can have this value from the graph. Kita sangkut dekat sini rate. Okay, kita sangkut dekat sini rate because kita, we do have time here. Okay, kita nak kena cari pula dia punya rate pula. Kan tu banyak kerja kan. So, let's not go for this one. Cari yang mudah. So, pakai T-half je. Pakai T-half sahaja yang mudah hidup kita. Masukkan dalam T-half. Dapatlah. Okay. Okay. Next. Apa soalan dia? Calculate the rate of decomposition of H2O2 when the concentration of H2O2 is 0.4 molar. Okay, rate of decomposition. Okay, so we have determined the rate constant just now. So we can find out the rate using the rate law. Ni barulah boleh guna this one. The K has been determined. The concentration also we can choose any of the data. Bukan, tak payah. Dia dah bagi dah. Okay, it's given. Okay, so you can insert into the rate law and to find the rate. Okay? Right. Itulah ceritanya.